friends, I welcome you all in this session. As you are aware, in previous session we discussed questions on one sample, one tail t-test. We have seen questions on hypothesis testing of proportion, wherein we have used z-test and it was a two-tailed test, right. Let us look at one more example on hypothesis testing of proportion. And the question is like this: a marketing company claims that it receives 8% responses from its mailing. So, this is the claim of the company, 8% responses the company receives from its mailing, right. Now, you want to test whether this claim is correct or not. So, what you have said, what you have done, you just collected a sample of 500 respondents or samples and you found that only 25 responses. So, you need to test this hypothesis at 0.05 significance level. So, how would you solve this question? A marketing company claims that it receives 8% of responses from its mailing. To test this claim, a random sample of 500 was surveyed with 25 responses. Test this hypothesis at 0.05 significance level. So, you have to take couple of decisions over here before solving this question. So, you need to first frame what is your null hypothesis and alternative hypothesis, right. And then what, whether you would be using t test or z test, right. So, the null hypothesis here is that the company's claim is that it receives 8% responses. So, it is 0.08, right, 0.08 is null hypothesis, and alternative hypothesis that it does not receive this much responses from mailing list or from mailing, is not it. So, this is a case of two-tailed test, two-tailed, what, whether it is t test or z test. Do you think there are two conditions you are fulfilling of applying t test? If you do not fulfill those two conditions, then use z test. So, here you would be using which test? Z test, right. So, and the significance level is 0.05. Since we are using z test, what would be the critical limits, critical table limits? That would be 1.96, is not it. I think by this time you would have understood that at 0.05 significance level z values are 1.96 both sides, right. So, this is your null hypothesis, population proportion is 0.08 and it is not 0.08, right. Now, this is your sample proportion, right, and how did you get this p value? How should you be getting it? Since pi is known, right, it is 0.08, it is 8%, right, it is there in question itself. So, this is 0.05 alpha and this sample proportion is 0.05. How did you get this? Because in a sample of 500 which you surveyed, you just saw 25 responses, right. So, it is 25 by 500, right. So, it becomes 0.05, is not it. So, that is why p is equal to this, pi is equal to this, and this is standard error of proportion. This is what is there. So, you should calculate z statistics as minus 2.47, and of course, your critical values are 1.96, right, plus and minus. So, compare your calculated z value with critical values. So, this is this in rejection region, right, this minus 2.47 is rejection region. So, you will reject the null hypothesis. So, there is sufficient evidence to reject the company's claim of 8% response rate. So, we will say that the response rate is not 8%, right. We are saying that this is not accepted. In other words, we have rejected this and we have accepted alternative hypothesis, right. It means the response rate is less than 8% or more than 8%, right. So, let us look at one more example on hypothesis testing of proportion. In fact, the same question you can solve using p value approach as well. So, this is a case wherein z value is 1.96. Now, at 1.96 you need to look at the probability values. For that you need z table. So, let us look at what are those values is there in z table. So, at 1.96 this is 1.9 and this is the one, right, 0.475, right. So, we are interested in this area, right. This is 0.49, no, that is not the value. In fact, yeah, at z, let us look at z is 2.47, 2.4 and 7 is 0.4932, right. So, z value which we have calculated is 2.4, right, 2.47, right. So, at 2.47 the area under curve is 0.4932. So, this is 0.4932, this area is so this area is in fact 0.062, because this area is 50%, right, 0.5, and we are interested in this area, right. So, 0.5 minus 0.4932 and this is the area this side, and similarly on right side you will get the same value, same area, right. So, you just add these two, you will get p value or probability value. So, this is 0.01362. Is p value less than alpha? Yes or no? Is p value less than alpha? So, p value is less than alpha will reject null hypothesis, right. So, this is what you should take a decision using p value approach, right. So, using critical value approach we rejected null hypothesis, is not it. Similarly, using p value approach we have rejected hypothesis, and you can use in fact the confidence interval approach as well to confirm this particular finding of rejecting this null hypothesis, right. So, let us look at one more example. So, this question is on hypothesis testing of population proportion for using two-tailed test, right. So, there is National Safety Council. Now, for Christmas and New Year's week, the National Safety Council estimated that 500 people would be killed and 25,000 would be injured on the nation's roads, right. This is what the National Safety Council estimated, right. The NSC claimed that 50% of the accidents would be caused by drunk driving. The council claims that the 50% of the accidents would be caused by drunk driving. The council takes a sample of 120 accidents and showed that 67 were caused by drunk driving. Use these data to test National Safety Council's claim. And what is the claim? That 50% of the accident would be by drunk driving, but when they took a sample of 120 accidents, there were only 67 cases of drunk driving. So, what would be the null and alternative hypothesis here? Just look at this question once again, read this question carefully and try to formulate null hypothesis and alternative hypothesis. So, the NSC claimed that 50% of the accident would be caused by drunk driving. So, this would be your null hypothesis, right? This H naught is equal to 0.5 and alternative hypothesis would be it is not equal to 0.5, is not it. So, this is a case of two tail test, right. In the beginning itself we have said, but by reading the question and by analyzing the situation, you should be able to frame null hypothesis as well as alternative hypothesis. Now this is a case wherein you have to apply either Z test or T test, right. So, how would you take the decision? It is a case of T test or Z test. Let me give you this part of the question as well. A sample of 120 showed that 67 were caused by drunk driving. So, you get any hint or not? So, this is a simple case of Z test, right. Okay. So, you would be having, let us say, the first step is you have formulated null hypothesis and alternative hypothesis. This H A is P is not equal to 0.5, level of significance 0.5. We can calculate the appropriate Z statistics, which is Z here, Z is 1.28, right. Since this is a case of two tailed race, right. So, how the distribution would look like, is not it. So, it would be like this, is not it. So, you have got these two are rejection region, right, and hypothesized population parameter is 0.5, is not it. Z calculated is 1.28 and what would be the table value of Z? Of course, it would be 1.96, is not it, because significance level is 0.05, right. So, this is minus 1.96, this plus 1.96 and calculated value is somewhere here, right. This is this somewhere here, right, 1.28, not here, somewhere here, is not it. So, you will reject or not reject null hypothesis, since the calculated Z value falls in critical range. So, we will not reject null hypothesis, and we will say that the 50% of accident would be by drunk driving, right. So, this is how you can solve a question like this. In fact, in this question you will get the same answer using p value approach as well. So, we will not reject null hypothesis because p value is more than alpha, is not it. So, we will not reject null hypothesis. The same is the decision we took here. We are not rejecting null hypothesis because calculated Z value is in non rejection region. So, we will not reject null hypothesis and same is the answer using P approach or probability approach. So, let us look at couple of exercise on hypothesis testing of one sample test using t test or z test, using one tail test or two tail test, right. So, we have worked out lots of examples on this, and now we will move on to exercise, right. So, let us look at first question, and you have to tell me whether this is true or false. In hypothesis testing, we assume that population parameter takes on a particular value before we sample. This assumption to be tested is called an alternative hypothesis. What do you think? In hypothesis testing, we assume that some population parameter takes on a particular value before we sample. So, this assumption is to be tested is called alternative hypothesis or some other hypothesis. So, this is called null hypothesis, right. So, this statement is false, right. Let us move on to question number 2. Assuming that a given hypothesis about a population mean is correct. So, we know that the given hypothesis about population mean is correct. The percentage of sample means that could fall outside certain limits from this hypothesized mean is called the significance level. Is this correct? The percentage of sample means that could fall outside certain limits from this hypothesized mean is called significance level. Yes, this is called significance level. So, this is true. So, let us look at next one. In hypothesis testing, the appropriate probability distribution to use is always the normal distribution. Just read this sentence carefully. In hypothesis testing, the appropriate probability distribution to use is always the normal distribution. Is correct? Do we always use a normal distribution or z distribution? No, we sometimes use t distribution as well, right. So, this statement is false, right. Let us look at the next one. If we were to take type 1 error, we would be rejecting a null hypothesis when it is really true. So, what is type 1 error and type 2 error? Just think over it. If we were to make a type 1 error, we would be rejecting a null hypothesis when it is really true. Yes, when we reject a true hypothesis, it is called type 1 error, right. So, this is true. Okay. Let us look at point number 5. Testing on the raw scale or standardized scale will lead to the same conclusion. Testing on the raw scale or z scale will lead to the same conclusion. So, you should know what is in fact there is nothing but z scale, right, or z values, right. Raw scale means the x values of that particular variable, right. So, what do you think? Testing on the raw scale or the standardized scale will lead the same conclusion. Yes, it will lead the same conclusion, right. Let us move on to the next question. If 1.96 is the critical value of z, if 1.96 is the critical value of z, then the significance level of the test is 0.05. Significance level means alpha. Is this true? What do you think? If 1.96 is the critical value of z, the significance level of the test is 0.05. this is false statement. In fact, you should know how to calculate or how to find out probabilities for given z value and how to convert, let us say, z values into probability, right. So, you need to know how to look at table carefully. So, sixth number is false, right. If our null and alternative hypothesis are this, null hypothesis this and alternative is less than type, it is appropriate to use left tail test, because this sign is less than type. So, we will use left tail test, right. So, it is appropriate to use. So, seventh is true, is not it. Had it been like this greater than 80, then we would have used right tail test. If it had been not equal to, then we would have used two tail test, right. Let us look at eighth one. If the standardized sample mean is between 0 and critical value, then you should not reject null hypothesis. If standardized sample mean is between 0 and critical value, then you should not reject null hypothesis. It means there is a situation like this. So, this is your 0 value, right, and this let us say this is your critical value, and this standardized sample mean is between this, right. So, then you should not reject null hypothesis. Yes, you should not reject null hypothesis, this is true, right, or let us say this is one more critical value, right. So, these are critical values and your sample mean is in this range. 1 minus beta is known as power of test, is it correct? In fact, we have seen relationship between type 1 and type 2 error, wherein we have said that 1 minus beta is power of test, right. What does it mean? What do you mean by power of test? Power of test is the probability of rejecting a null hypothesis when it is false. So, that is power of test. So, this statement is true. Let us look at the next one. After performing a one tail test and rejecting null hypothesis, you realize you should have done a two tail test at the same significance level. You will also reject null hypothesis for that test. Keep in mind, you wanted to have a two sample a two tail test, but you just used one sample one tail test, right. So, do you think that the result would remain same or the result would be different? Would you still like to reject null hypothesis? So, this is false, your answer will change, is not it, because you will have two rejection regions in this case, right. So, your answer might change, is not it, but it will not, it may in fact it will change, is not it. So, this is false, right. Let us look at the next one. It is often but not always possible to set the values of alpha so that we obtain a risk free trade off in hypothesis testing. It is often but not always possible to set the value of alpha. Generally, we set the value of alpha in second step, right, before deciding on whether you would be using t test or z test, right. So, it is often but not always, in fact it is always possible to set the value of alpha. So, this statement is false, is not it. So, you set the value of alpha a priori, right, before calculating t statistics or z statistics. Let us look at next one. You are performing a two-tailed hypothesis test on population mean and have set alpha is equal to 0.05. If the sample statistics fall within 0.95 of area around this, around hypothesized population mean, you have proved that the null hypothesis is true. Is it correct? What do you think? You are performing a two-tailed hypothesis test on a population mean and have set alpha is equal to this. If the sample statistics falls within 0.95 of area around 0.95 of area around this, you have proved that null hypothesis is true. No, this is completely false. In fact, when you say, in fact, you can prepare a distribution for this question and then you can draw your rejection region and non rejection region, right. In fact, it is not 0.95 of area, but it is from the sample statistics has to fall within critical limits, right. Then you would have said you would have not rejected the null hypothesis and you would have said the null hypothesis is true, is not it. So, you need to look at critical values. Let us look at the next one. If hypothesis tests were done with significance level of let us say 0.60, right, significance level is 0.60. So, this is your alpha value, is not it. So, alpha value is this, it means this is 30%, this is 30%, right. So, this is and remaining is 40%, right. The null hypothesis would usually be accepted when it was not true. What do you think? Why do we test, why we do not test hypothesis at high significance level? In fact, in one of the slides I have taught you about why we do not test hypothesis at high significance level, because there is a probability of rejecting a null hypothesis which is true. So, this statement is false, right. In fact, the null hypothesis would usually be rejected when it was not true. Okay. So, at high significance the null hypothesis would be rejected if it is true, right. Okay. So, this is a false statement, right. Let us look at 14th one. If hypothesized population mean is 50, alpha is 0.05, then 1 minus beta must be equal to 0.95 when mean is 50. What do you think? Is this true statement or false statement? 14th. If hypothesized population mean is 50, alpha is this, then 1 minus beta must be equal to this. In fact, this is not 1 minus beta, this is 1 minus alpha. So, this statement is a false one, is not it. So, 1 minus alpha would be equal to this, right. So, with alpha and beta you can find out whether this statement is true or false. So, let us move on to 15th one. For a given level of significance, the critical value of t get closer to 0 as sample size increases. What do you think? For a given level of significance, the critical values of t get closer to 0 as sample size increases. Yes, it happens. So, this statement is true one. Let us look at the 16th one. Selecting the appropriate significance level is easier than selecting the proper test to use. What do you think? Selecting the proper significance level is easier than which test is to be used or to be applied. What do you think? Is it correct statement? In fact, it is very difficult to decide the significance level, but it is easy to use. It is easy to decide whether you want to use t test or z test, right. So, this statement is not correct. This statement is false. Let us look at the next one. Mathematical methods exist that guarantee that the significance level chosen will always be appropriate. So, do you have mathematical methods which would tell you that significance level chosen or the chosen significance level was a correct one? In fact, you do not have any such mathematical methods, right. So, this statement is false, right. 17 number is false. Let us look at the next one. Hypothesis testing helps us draw conclusion about estimated parameter. Is it correct? Is it correct? 18th one. Hypothesis testing helps us draw a conclusion about estimated parameters. Yes, about we generally estimate population parameter first, or we assume population parameter, and on the basis of that sample we prove or disprove our hypothesis, right. Let us look at 19th one. A hypothesis test will be useful in determining whether a population mean is 45 or 60. A hypothesis test will be useful in determining whether population mean is 45 or 60. So, null hypothesis is this and alternative hypothesis 60. Is this correct? Hypothesis test will be useful in determining whether population mean is 45 or 60. Given null hypothesis this, alternative hypothesis this. No, it is not possible, is not it? So, you can have either 45 over here, is not it? If not 45 over here, and if you keep 60 over here, then you need to keep 60 over here, right. So, this statement is false, right. So, let us look at one more. Hypothesis testing cannot unequivocally prove the truth about value of population parameter. Hypothesis testing cannot unequivocally prove the truth about the value of population parameters. So, what about this? Yeah, it can prove in fact. Hypothesis testing is a procedure which can unequivocally prove the truth about the value of population parameter, right. So, this statement is true. So, we will look at these two questions as well. The power of hypothesis test is appropriate only for use with one tail test. The power of hypothesis test is appropriate only for use with one tail test. Is this correct? What is power of test? It is 1 minus beta, is not it? Is appropriate only for use with one tail test, or it can be used for two tail test as well. Just think over it. Yes, this is false. We can use it for two tail test as well, right. So, this is false, right, 21 number is false. Okay. Let us look at this question, 22nd. A major automobile manufacturer has had to recall several models from its 1993 line due to quality control problems that were not discovered with its random final inspection procedure. This is an example of type 1 error, type 2 error, both type 1 and type 2 error are neither type of error. What would you do? Let me tell you, the answer cannot be C, is not it, because you can't have both the errors simultaneously. So, either you are committing type 1 error or type 2 error, and of course, this also cannot be answer, because the answer is somewhere is either A or either B. So, let us recall what is type 1 error. Type 1 error is an error when you reject a null hypothesis when it is true, right. So, this is a case of type 1 error. In fact, we have seen couple of examples on type 1 and type 2 error. You can always refer that lecture on type 1 and type 2 error. Now, let us move on to the next one. If n is equal to, let us say 24, alpha is equal to 0.05 and the critical value of t for testing the hypothesis for less than type, right. So, this is a case of low tail test, right, left tail test where n is equal to 24, right. So, what would be the t value? You need to look at t table for this question. To answer this question, you need to refer to t table. So, at what degrees of freedom you should be looking at? You should be looking at 23 degrees of freedom, is not it? And under which column? Under which column? So, you need to look at 0.90 column, right. So, the t value would be for this question, it is this. So, this is in fact left tail trace, right. So, this minus 1.714, this value, right. Okay. So, this is a very simple question, you can easily find out answer to this one. Let us look at the 24th one. To test hypothesis about the mean of normal population with known standard deviation, we can compute. So, standard deviation is known and we are testing a hypothesis testing of population mean, right. Now, the observed value of x with the x. So, we can compare what? The observed value of x with critical value of x bar, the observed value of x bar with critical value of z, the observed value of z with critical value of x bar, the observed value of z with critical value of z. So, what is the correct answer? To test hypothesis about the population mean of a normal population with a known standard deviation, we can compare what? In fact, this is the right answer, A or D, right. So, A is, so of course, observe the value of z with the critical value of z, then only we will take decision whether to reject or not to reject, or you can have this situation as well, is not it. So, either this raw scale and this is standardized scale or z scale. Let us look at the next one, 25th. If we say that alpha is equal to this for a particular hypothesis test, we are saying that, what does it mean? 10%, the 10% is our minimum standard error for acceptable probability. 10% is the risk we take of rejecting a hypothesis that is true, What is alpha? Alpha is also known as type 1 error, right. Okay. 10% is the risk we take of accepting a hypothesis when it is false. A and B means these two are A and C, A and C, A and C, right, these two, which what is correct? Yes, please. So, the answer is A and B only. So, 10% alpha is nothing but we are taking a risk that we reject the hypothesis when it is true or accept when it is false, is not it. So, in this session we discussed about different questions on hypothesis testing of one tail test, two tail test, T test and Z test. We will continue with some more questions in next session. Thank you.